Okay, this test is going to be 20 questions long, all about sequences and series of all kinds. I'm going to show you what it's going to be, and you want to write it down, and then come see me after school if you feel like you're going to have trouble, because it's going to be tomorrow. Try to get the formulas memorized and know when and where to use them, because you have a card, and it can be a 3x5 card with stuff on one side, and it cannot have any worked out problems.
Oh, but that costs you 10 points.
Yeah, and if you have that, you can't have any worked out problems. What you can have are formulas and statements in English about what each of those pieces of the formula represent, but that's all. Can't have any worked out problems, okay? All right, number 1 on the test. And number 2, both of them. They say, write the first 6 terms of the sequence. These do not have to be arithmetic or geometric. They may be, but there are other kinds of sequences out there. So what you've got to do is look at what's offered to you. It'll say AN equals, and then it will have some formula with an N in it. Put 1 in for N, figure out a number, write it down. Put 2 in for N, figure it out, write it down. Put a comma in between each one until you've got 6 of them. That make good sense?
Yeah.
Okay, I'm not writing anything on the board then. Do you want me to do one?
Maybe
Yeah,
just
I
like
can see
real
what
quick.
you're kind of talking about.
All right.
I just kind of want to go and see what it's going to look like.
I may not be able to get 6 terms because this may get really big really fast, but if I have this for formula, AN equals, well, we'll just say 2n squared minus 8. Put a 1 in there, you're going to get 2 minus 8 for your first term, which is negative 6. You understand that? You put 2 in there, you have to square first. You have to follow order of operations. 2 squared is 4. 4 times 2 is 2, or 8, and 8 minus 8 is 0. Then you put 3 in. That gives you 9 times 2 is 18, minus 8 is 10. You see what's going on? You got 3 terms there, so that means 4 goes in next. That's 16 times 2 is 32, minus 8 is 24. You got to do 2 more by putting a 5 in there. It'll be 25, and 50 minus 8 is 42. You're going to put a 6 in there. 36 times 2 is 72, minus 8 is 64. See it? Can't do the arithmetic that fast, then make your calculator do it, but that's what you do. You put each successive number from 1 to 6 in there and write them down as you get them with commas in between. Good? That's the first 2 questions. Numbers 3 and 4 are under these instructions. Describe as arithmetic or geometric, so it'll be one of the 2. Write the next term and write a rule for the nth term. 3 things. Decide what it is, write the next term, and write a rule for the nth term. This is what your answer page looks like for these. I don't know if you can see it very well. And it's kind of hard to see, but right here on these 2 it says AG, circle 1 for arithmetic or geometric. That's what that stands for. Circle 1, what you've decided. Then it says what did it say, good term? Oh, it just says the next term. So there's 4 terms, because right here it says A5 and A5. So you fill in the next term, which will be the 5th term. So I'll give you 4 terms. And then you've got to give me a formula for the nth term. That's what the whole thing's needed. You go to that? And for those of you watching here, this is what I'm talking about right here, these 2. Circle A or G for arithmetic or geometric. Fill in the next term, fill in the nth term. Okay? Okay. Okay, so that's 3 and 4. You need to see one of those. We good? Okay. Number 5. It's a standalone problem, and it says, write the series. What's a series? Sequences have commas. Sequences are a list. Series are a number. It means add them up. Yeah. And so this series will be offered to you with plus signs in it. Doesn't tell you what kind it is. It just gives you a bunch of plus signs. So you treat them as though they were commas and try to figure out if they're arithmetic or geometric. And it says, write the series using summation notation. And this is what it looks like on your answer sheet. It's not very big. I made it as big as I could without making too much space. It just gives you a Greek letter. And you've got to fill in the bottom and the top with whatever variable you want. If you use n, then you would say n equals 1. I would never go anything with 1. That just makes trouble for yourself. Put the top number up here, and then put the formula for it right out here, whether it's arithmetic or geometric. And what goes right here is the nth term formula. And if it's arithmetic, you got a little cleanup to do. If it's geometric, you just plop it in there. You can't clean that up. Can you see one?
Yeah.
All right. This is what I was showing everybody. See the summation symbol? You got to fill in all the gaps for number 5. Okay. So the objective is to write this series, which has plus signs in it, in summation notation. This is what we did yesterday.
Yeah.
I don't know if I can make up another one very effectively. I'll try it. I gotta get my calculator.
Like 5.
I'll be able to calculate some things here. Okay, so let's say it was a series like this. -7, oops, plus -4, well, I'll say minus, no, I'll say plus -4, plus -1, plus 2, plus dot, 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 plus. $47. Okay, you are to write that in summation notation. So, first of all, what kind of a series is it? Who's supposed to?
Jonathan.
Okay. So, first we need an nth term formula. You've decided it's arithmetic, so AN is going to be equal to what? -7, good.
It's plus.
Good. N minus 1 times 3. Everybody understand where that all came from? There's a gap of 3 between each one. In other words, take any term minus the one before it. 2 minus -1 is 3. That's the common difference. And the first term is -7. If you have your nth term formula memorized, you'll understand where these came from, I hope. You get it? This one, because it's arithmetic, requires a bit of cleanup. It's -7. We got to distribute, so it'll be plus 3n minus 3. And -7 minus 3 is -10. So it's 3n minus 10. We good? So when we go to do the answer thing, the summation notation looks like this. You would say n equals 1 and 3n minus 10. And this is the most important part. This will get you more points than these will. How do we figure out how far we're going to count up to? That's what it has. Right. So you got to put 47. That's the value of the nth term is equal to this. And figure out what n is. So it'll be 57 equals 3n. 19 equals n. You agree?
Yep. Yeah.
There you go. And this is what I expect to see for the answer for that, just in case you're wondering. This is the sporting work. Y'all see it?
Yeah.
Okay, we practiced that yesterday. That was kind of a hard problem. A lot of people missed that, but maybe you won't because we practiced it pretty well yesterday. Now, it could also be geometric. Do you know how to handle that? Same way. Except for you, there's no cleanup here. There's none of this. And once you write this, that's what goes here. And then you have to put the last term in for the nth term and then solve for n. Yeah? Okay. Okay, ready for the next ones?
Yeah.
There are 4 problems next. 6, 7, 8, and 9. And they have a very, very simple instruction. It says find the sum. And every one of them is expressed in summation notation. So they're going to give you the summation notation. And you are expected to come up with the sum, which is a number. So 6, 7, 8, and 9 are all just numbers. And I will tell you this, sort of ease your mind just a little bit. If you know how to read summation notation, none of the top numbers are big enough that you won't be able to just muscle it through by finding each term and adding them up. If you know how to handle the summation notation. If you also know the formulas that go with them, then you can do them quicker. Or maybe have an alternate method to check your other one with. But there is a way to tackle these problems without having formulas memorized. Because the top number is not big enough to prevent you. I would say that that's big enough to prevent me from writing out 19 terms, but I suppose we could. But none of them are like 50 or 38. They're all single digits. And they all, one of the three does not start with the number 1. Do you remember why that's important?
Yeah, 'cause it's like the top one minus the bottom one plus one.
Gives you n. If it starts with 1, then it is the top number that's in.
Yeah.
You know, the top number is in. If it doesn't start with 1, then you got to find n a little bit. It's got a little bit harder. The top minus bottom plus 1 to get your n value to put in a formula. Or just start with the one they tell you, and end with the one that they end on, and add up those numbers that came from plugging them in. You see, or not? These problems are very, very much like numbers 1 and 2, except that they're offered to you with that funny looking Greek S instead of just a formula. But it's the same idea if you know how to read the pieces of it. Do you need to do one? Do we need to do one?
Just doesn't do one. Yeah.
All right. Keep in mind, I'm making this up, which means the numbers could get out of control pretty quick, but if you've got a calculator, they've got to be really out of control to make it impossible. So, to give you a summation notation like this, give you something like this, and it says find the sum. And it will say n equals, do you want me to do one that starts at 1 or not? You want a different one? Let's start at 3 and go to 9. That'd be okay?
Yeah.
Of this formula right here, let's say, 2 times, oh boy. Not 2. Maybe, well. I'm just going to say 2 to the end. Nah. I'll put a 1/4 here. Okay. So this is the way I would do it if I didn't know a formula. And I'll show you how to do it with a formula so you can check. I would say, well, I'd put a 3 in here for n. What is 2 to the 3rd? 8. What's a 4th of 8?
2.
2. So that's your first one. Put a plus sign because you're going to add these up, right? What's the next number I'm going to put in? 4. And 2 to the 4th is 16, and a 4th of that is 4. Am I losing anybody? Yeah, put a 3 in, I put a 4 in, now I got to go to 5. If you can't keep track, just count how many you got. This would be 3, 4, and I've got to put 5 in next. 2 to the 5th is 32, and a quarter of that is 8. Am I going too fast?
No.
Okay. All right, so that was 5. That was 3, 4, 5. So I got a 6. 2 to the 6th is 64, and a quarter of that is 16. Can you see a pattern here?
Yeah.
It looks like
It's the number times 2.
it's the number you've got plus the next, plus the previous one. Oh, okay. So this will be, so this was 3, 4, 5, 6. Then 7 will be 32. 8 will be, okay.
And then 120.
Well, that wasn't so bad. Let's see if that actually works for that last term. If you put a 9 in there, what is 2 to the 9th? Would be the same as 2 to the 7th. Because this is 2 squares, right? 5. Is it 128? If you put 9 in for n, 2 to the 9th divided by 4? 128? Then you grab your calculator and add those up. That's not so bad, right? Okay. Is this arithmetic or geometric? And what is the sum of a geometric?
N divided by 2.
A1 times 1 minus r to the n over 1 minus r. That's what it is. Remember? If you apply that to this, then what are you going to put in for A1? Whatever you get for plugging in 3. Whatever that is, even if you didn't generate this first. So that would be 2 times 1 minus, what is r? 2. What is n? This is the clincher. It is 7. That's the one that's going to kill you if you use the formula if you don't know what you're doing. It's 9 minus 3 is 6 plus 1. That's n. You following? Okay. And then over 1 minus r, which is just 1. So I have 1 minus 2 to the 7th 2 to the 7th is what?
Let's find out.
Is it 128?
Yeah, it's one.
Yeah, so 28 is negative 127 times 2 is what?
127 times 2, that is 254.
Is that what those add up to?
Yeah, but they're positive and that would be negative. Yeah.
No, it doesn't, because 1 minus 2 is negative 1.
Oh,
It's okay, I didn't consider that, but no, you're right. This is a negative value up here, and then 1 minus 2 is negative 1, so it's a negative divided by negative, okay. We good? Okay, so this is a way you can do it with a formula, this is a way you can do it by just muscling it through. This one doesn't make you figure out an n value, this one does. If you want to check it, make sure you're doing it right. Because if you figure the wrong n value and you get a bad number here and a different number here than you get here, you're gonna wonder which one's wrong. So you gotta be careful.
So what do we do different with n equals 3 than you would with n equals 1? You just have to.
You just start at 1 instead of 3.
You'll get 2 more numbers in the front.
So instead of plugging 3 in for your first number.
And if it were from 1 to 9, then n would have been 9. When you go to check it, you know what I'm saying? Okay. All right, I will tell you this, on 6 to 9, the ones we're talking about, 2 of them are arithmetic and 2 of them are geometric. Okay. All right, number 10. I love the way they phrase these things. It's a story problem. So you're gonna have to put together your own sequence to figure out what the answer to the questions they have. Here's the deal. It says, you are enjoying reading in your free time.
Wow.
And you keep every book you have read.
Shoot.
That sounds a little bit criminal, unless you buy them. Right?
I just take them for my race on.
Anyway, you're hanging on to every single book you read. Then, here's what it says, and I'm not going to give any more details than this. It says, when you were 6 years old, these are numbers are being changed, but when you were 6 years old, you read a certain number of books. Every year after that, something happened to that number of books that's predictable. Either you added the same number of books to it, or you added twice as many books to it, or you multiplied it by 4. I don't know, something like that. But it'll give you some indication of what's going on and how the number of books is increasing as you get older. And the question says, how many books did you have if you kept every one you read? How many books did you have in your bookcase when you were 14? That's a series problem because you have to add them all up. Again, you're starting when you're fairly young and you won't get more than 14. So again, if you can figure out by the change in things what happens every year and count them up, then you can just add them up. You won't have to have a formula memorized, but you have to be able to figure out the words and what it means for a sequence or series because you got to add them up. You follow me there? Yeah, that's all I'm telling you about that one.
Is there like any examples in the book like that one?
I don't know, maybe. If we have time, I'll look it up. Remind me. Remind me to find you a sample like number 10. I'll try it, see if I can find it. Does anybody remember doing something like that on the review? Because I think I handpicked problems to match pretty well. No story problems on the review? Do you recall? Okay, all right.
Isn't what we just did, isn't it just what we just did, like in a story problem?
Yes, but you'll have to decide based on the words in the description whether it's arithmetic or geometric and follow the rule that they give you that I'm not telling you about and find enough numbers to add up. All right. Shh. Number 11. It says, write a rule for the nth term of the sequence and then find the 13th one. So it gives you the first 4 numbers in a sequence. It's got commas in between. It gives you the first 4 numbers and it says, write the rule for the nth term of the sequence. It doesn't ask you to decide if it's arithmetic or geometric, but you probably should. And then write the rule for the nth term and then find the 13th term using your rule. Or just continue the sequence out till you got 13 and then write that down. But if you've written a rule for the nth term, you might as well use it. But if you can't write that rule, you can still find the 13th one if you must look for it. That's what's going on? It's either arithmetic or geometric, I'm not going to tell you which. Do I need to do one like number 11?
Yeah, we do one like that.
People, I swear.
Is this number 10?
It's like you guys want to do any thinking for yourself. You guys come up with the sequence. Give me the first 4 terms in a sequence. Go.
1, 2, 3, 4. No.
We can do that one. I don't know how enlightening it would be, but give me a sequence. First 4 terms in a sequence. 2, 4, 8, 16. Find a rule for the nth term. What is it? You have to decide that first. Arithmetic or geometric? Geometric. What is the formula for the nth term of a geometric in general?
N minus 1.
How does that work for this one?
2 times 2 to n minus 1.
There's your nth term. What is the 13th one?
Oh, we just put 2 in there, so 12. 2 times 2 times to the 12.
Yeah, so it's really 2 to the 13th because these have to be the same. But if this were 3 here, you would take 2 to the 12 times 3.
8,000.
So 8192.
There's your sample. Okay? Doing okay? Y'all understand what happened there, or do you want me to go over it more slowly? Court keeps trying to peek around Wyatt over there, and I can't tell what his face is saying because his neck's all stretched out. Okay, that's number 11. All right. This one, this 12 and 13, and also 15 and 16. I'll grab 14 for you, I promise, but 12 and 13, and 15 and 16, these are the ones where people lose their grade. So I'll show you how it goes. These are really hard to make up, so I've got to find one in the book. Hang on a minute. Okay. This one, 12 and 13, if you want to write this down on your notes so that you've got lots of practice problems.
Students, we have approximately 10 tickets for the girls' state tournament. If there's any student that would like to attend, it must be 100% certain that you will attend. If that's something that interests you, please come to the office. Thank you.
If you want to go get that, that's fine. You can watch the video later. You got to have money and 100% intent before you can go down. Okay. All right, so number 12 and 13 are just like 31 to 38 on page 423. So if you'd like to practice these and make sure you can do them by yourself, top to bottom, 100%, get them right, those would be the ones to practice tonight. 31 to 38 on page 423. Okay? I'm going to do one for you. 4, 2, 3. 31 to 38. I'm going to do number 34 for you. 34 on page 423. Of those problems, I'm doing number 34. A8 is negative 15. A17 is negative 78. A8 is equal to, we're going to say
3 hours.
A8, negative 15. Was it 17? Anybody even turn the page? Right, okay. Negative 78. And one thing you have to pay attention to, so you make sure you use the right thing here, is that is for arithmetic. So are those problem numbers on the test. The first 12 and 13, it says, write a rule for the nth term of the arithmetic sequence. This is all the information you get. So you got to first know it's arithmetic. And that's the 8th term and the 17th term. That's all you get. So what you do is you write the nth term formula as much as you can fill in from this. This is n. This is an in a general way. So for this one right here, you would write negative 15. That's an. That's the value of it. Equals a1. You don't know that, so you have to write just a1. Plus n minus 1d. N minus 1 is 7.
Oh, yeah.
Y'all see what I'm doing? 7d. And what that is an equation. From just this information here, it's an equation, but there's still 2 unknown variables. There's an A1 and a D. We don't know either one of those yet. But we were able to fill in this and this. Do you see? We're not. Yes or no? Yeah? So how do I write this one? Plus 16D. And at this point, you have three choices. Listen up. Shh. You have three choices. You can solve these. This is, by the way, this is a system of equation. Like you ran into in Algebra 1 when we have to do something like this, like 3x plus 2y equals 7 and negative 4x plus 7y equals negative 8. Remember seeing something like this and you'd try to get one of them to add out and solve for that one. And when you get that one, you come back into one of these and find out what the other one is. Remember that? Called solving a system. That's what you have here, is a system. And the variables are A, 1, and D instead of X and Y. You following me? So, if we were to stack them up so that they look like a system, I bring this one over here. You don't have to do this, but it just looks more familiar if you do. Then the objective would be, right at this point, you can get the A1s to add out by simply running a negative through one, and the A1s will add out. You could solve for A1 in either one of these things and substitute A1 with it so you have an equation written only in D. Or you can use your simultaneous equation solver on your calculator. But you got to know where it is and how to use it. All of these things require a skill. The first skill is write the dang system. If you can't write that, you're dead in the water. And this is worth a lot because there's a lot to it. A lot of places to make mistakes, a lot of things to know to get it solved. So it's worth a lot. I hope you can do this. So here's what I'm going to do. I'm going to go to my calculator and I'm going to go apps and then polysumult or polysumult 2. And I'm going to choose the second choice, which is simultaneous equation solver. Y'all see it?
Yeah.
So I'm going to choose that. And the first thing it asks you is, in case you've forgotten what that's the first thing it's going to ask you is, how many equations and how many unknowns? What's the answer to that for this? 2 and 2. So if they are not already marked 2, then choose those and hit enter. And then hit the next key, which is in the lower right. That's your graph key. Then you've got to fill in these variables. Now this is backwards from the way they want it. Usually the variable stuff comes first, like the x and the y, and then the constant. We got the constant here, so you got to read it right. What I'm going to put in is 1 and 7 and negative 15. You with me? Yes?
Yeah.
Okay. 1, enter, negative 7, no, positive 7. 7, enter, and then negative 15. Then in the next one, I'm going to also put a 1. And a 16, and a negative 75.
78, right?
78, yes. I don't know what I was doing.
Oh.
I was talking while I was writing. That's what happened. So this is supposed to be a 78. Sorry, everybody that's watching online and everyone in the class. It's been a negative 78. Thank you for that correction. Okay. And if you hit enter after the negative 78, Grace was doing this with me yesterday. She forgot to hit enter. You have to hit enter so that it actually says negative 78 there. You got to hit enter, because if you don't hit enter, it won't put that one in there. Then hit solve, and we get 34 and negative 7. What have we got then? A1 is what? 34, and D is? D is negative 7, yes. So what's the nth term formula? Because that's the final answer. AN equals 34. N minus 1. Times negative 7. That's not what you put in the blank. You still have to clean it up. That's 34 minus 7n plus 7. That's negative 7n plus 41. That's what goes in the blank. And that is a lot of work and a lot of ways to make mistakes. And I only demonstrated how to use this. Does anybody want me to demonstrate any other method? Okay, I would suggest that you practice 3 or 4 of those until you can get them top to bottom without help and correct and show your work. Yes?
How much would one of these be worth?
I don't know. I've got my keys someplace. I'll tell you that. I would say it's probably worth 6 or 7, where most of them are worth 2 or 3 or 4. Okay, so 12 and 13 are both like that. 15 and 16, since we're on that, I'll come back to 14. 15 and 16 are like that, only they involve geometrics, which means this is not an option. You have to do 15 and 16 algebraically. on a piece of paper and figure it out with your head. Because this won't do it. This is only good for linear systems. Geometric things are not linear. They're exponential, right? We don't have an exponential equation solver. Okay, so this one's going to involve even more math, and it is missed by more people because the calculator can't be used for a crutch. So, if you want practice on these, and I recommend that highly tonight or at Math Lab, make sure you can do them top to bottom by yourself. That would be in the geometric sequence and series section, which is page 430. Page 430, numbers 33 to 40.
Page 430.
430, numbers 33 to 40. And I think I'm going to do number 40. That was part of your review assignment, right? Do you want me to do a different one? All right. Number 40 is A2 equals negative 48. A2 equals negative 48. And A, what's the other one? A5 equals 3. Okay? And it says clearly on the test and in these instructions, write a rule for the nth term of the geometric sequence, which means we start the same way, but we use the nth term of a geometric, which would be what is the general form for nth term of a geometric? Right? And in this right here, they've given you an n, if you know where to find it, and they've given you an an. So this one right here is negative 48 equals a1, which I don't know, r, which I don't know, but I do know what n is. It's 2, and 2 minus 1 is 1. Or you don't have to write that at all if you don't want. Now that's if you recognize it's just 1. Do the same thing for this. What do I write?
Equals R to the 4.
Okay, so now we have another system of equations, but it's not linear, and you can't use your calculator to solve it. You can only use substitution. What?
Is it like you solve it with you divide the R over negative 48?
Well, you solve one of them for either A1 or R, and it's strategic if you solve it for the right one. What do you suppose we ought to solve? This one I like better because the exponent is smaller. That's what I would go to first. Do we want to solve that for A1 or do we want to solve it for R? All right, so I have negative 48 over R is equal to A1. Y'all understand that move? Yeah? Then we apply the substitution notion and we come over here and replace that A1, because A1 is equal to this. We replace that with this, and we get this in that replacement. 3/4 equals negative 48 over R times R to the 4th. Y'all see that?
Yeah.
1 R will cancel. I got an R in the bottom, I have an R in the top. When I cancel it, I have how many left over? 3. So what I have is 3/4 equals negative 48 R to the 3rd. Will you buy that?
Yeah.
Now we divide 3/4 by negative 48. That's 3 over 192, I think. What I'm going to do in my calculator is I'm going to write parentheses 3 divided by 4, close it, divided by negative 48, enter, and then math, enter, enter. Negative 1 over 64. We're all able to make that calculation?
Yeah.
Okay. Then I'm going to cube root that. Because to get at that R, I've got to cube root both sides. You understand that move? So I'm going to say my answer. If I hit a raised 2k, it'll say answer raised to, and I'm going to put what?
I got negative 1.
1 divided by 3. What? If you cube root it, you get negative 1/4 is R. We good on that?
And you gotta go and plug in R to
Yeah. Now you've got to come back to here to figure out what A1 is. So take negative 48. So now we're coming back and putting this value of R, now that we have it right there, and try to figure out what A1 is. So it's a double substitution. I got negative 48 divided by negative 1/4. Put it in parentheses. Negative 1 divided by 4. Close it. Enter. And I get 192 for A1. Y'all see that?
Yep.
Quite a process. So what is the answer to the question?
Oh, 192. Minus 1.
Did you catch all that? And that one cannot be done in your calculator as far, well, you can do the arithmetic, but you gotta know what you're doing. You can only, the best method is a substitution method, so you get both of these written, solve the simpler one for A1, so you've got an R term over here, replace A1 with an R, get your R, come back, find A1, write the formula. It's quite a process. I would practice if I were you till you can do it, top to bottom, without help, and get it right. There's several practices right there. I have other books with more practice if you think you need it. You come get it after school. Okay, number 14. I'm going back to that. Number 14 is much like number 5. Number 5 said, write the series using summation. No, I'm sorry, that's not it. That's not what it was. I got to scratch that. Number 14 is much like number 11. 11 said, write a rule for the nth term of the sequence and then find A13. This one says the very same thing. Write a rule for the nth term of the sequence, then find A8. You have to decide what kind of sequence it is, write the nth term, and use it to generate whatever, A8 or whatever. Number 11 was what kind, do you remember? Was it arithmetic? Well, I'll tell you what, there's one of each. You've got to decide what it is, and there will be one of each for you to do that on. Okay. So we're down to number 17. Actually, yes, we are. 17 to 19 have one set of instructions. And here's what it says. Find the sum of the infinite geometric series if it exists. What do you write if it doesn't exist?
No sum.
No sum. And under what conditions would it not exist?
R is greater than 1.
R is greater than 1 or?
Less than
Right. So you can find the sum of an infinite geometric if R is between -1 and in other words, there's positive or negative proper fraction, right? Okay. In two cases, they just list the terms. So you have to decide what R is, make a decision on that, and then find the sum if it exists. And one of them is offered to you as summation notation.
If it's equal to 1 or -1, does it still work? Or is it more
If it's equal to 1 or -1, it cannot possibly be geometric because your R would be raised to whatever power, it always stay 1. So your sequence is 5 plus 5 plus 5 plus 5. It's not geometric.
So, but it's still
It has to be outside or inside that. It cannot be 1 or -1. Okay? Do you need to see? Do you need to see any of that? All right. Consider this one. This is what the way it's offered. Something like this. 14 minus, this is going to be easy, 14 minus 7 plus 7 halves minus 7 fourths plus 7 eighths minus forever. Will this have a sum?
Looks like it's divided by yours.
What?
No, negative.
Oh yeah, this one is trippy.
You need to find R, right? How do you find R?
Right number or left number. Right?
Take any term and divide by the one before it. So let's take -7 and divide by 14. What is that? Does that fit the bill for R?
Yes.
Then how do we find the sum? What is the sum of an infinite series in general? A1 over 1 minus R. Well, we've decided it has a sum. We just have to come up with those two things. We've already come up with R in making the decision if it has a sum. What's A1? So it's going to be 14 over 1 minus -1/2, which is 14 over 3 halves, which is 28 thirds. If you do the arithmetic. You good?
Yeah.
You sure or not?
Yeah.
All right. If these numbers are getting bigger, I mean the size of them, not the sign on them, but if the size of them is getting bigger, you're going to write no sum, because only an r greater than 1 or less than -1 can make the numbers get bigger as you go along. It's getting smaller, you're going to find a sum. It's getting bigger, you're not. Also, if it's offered to you like this, why no sum?
1.2 is good.
And 1.2 is what? R. R. Sum for this. What would you write for this? There is a sum, and what is it? Oh, by the way, sorry. This will say n minus 1 on it. What's first term? That's what goes here, right? That's your A1. What's R? 0.2. So all you got to do is take -48 divided by 0.8. And what is that? 660 or 600?
60.
Negative 60.
That's what it ends up to. Okay, so those three like that. You've got to decide if there is a sum, and if so, you got to find it. You have to have this formula memorized. That's A1 over 1 minus 1.
That's for an infinite geometric theory.
And the last one, and I'm not going to tell you how many, but the last one is simply a repeating decimal. And it asks you to write it as a fraction. Remember the rule on that?
Yep. Yeah.
Well, you can check what you get. So if you have 3 repeating digits, you put
3 9 over.
those digits over 3 nines. And make your calculator reduce it. I expect a reduced one since you got the tool.
So if that's both here.
We good? All right, that's the test. 20 questions. This is what the answer page looks like. It's pretty short. It's going to be easier for me to grade. I still use a lot of red ink usually, so don't be among those. So I told you the ones that'll kill you and the ones you really had better practice. Besides memorizing your formulas, you better practice those, folks. Just looking at it and saying, oh, yeah, I can do it. You better convince yourself. Because when push comes to shove and you got to do it all by yourself, a lot of times people have more confidence than they really should when it comes to doing it. Okay, folks, that was that review. Good luck. Bye. I think we're only missing one person.